streets, I'm a mobster. You got 50 whole bed, you'll be my sponsor. Them snakes on the plane, me and Kanye Conda. Yeah.
Okay, so we're told to find the vertex of the quadratic 2x squared minus 6x plus 7. So let me break that down a little bit. So we have f of x is equal to 2x squared plus a negative 6 times x, and then plus a 7. So this is our a, that's the coefficient of x squared. This is our b, which is negative 6, that's the coefficient of x, and c is 7, okay? So in order to find hk, our vertex, we have the formula h is equal to negative b over 2a, okay? And then we just plug those in, whatever we have as b and whatever is a. So negative b would be negative of negative 6 when we plug that in. And then 2a is 2 times a positive 2. So the negatives cancel out, as do a 2 on top and bottom. So we just get h is equal to 3 over 2. Okay, so we found the x-coordinate of our vertex, so 3 over 2 something. And to find that something, we just plug in our h into our function and find that value. So k is equal to f of h, which is equal to, now that we found it, 3 over 2, f of 3 over 2. So when we plug in 3 over 2, that's all we have to do. 3 over 2 squared minus 6 times 3 over 2, and then plus a 7. So we're just going to simplify here. We have 2 times a 9 over 4, and then minus 18 over 2 plus a 7. So this is equal to, what is this? Let's see. Those cancel out, so 2 and 2. So this is 9 over 2. 9 over 2 minus 18 over 2 plus, might as well throw it in, a 14 over 2. So this is like saying negative 9 plus 14. So that would be a positive 5 over 2 there for our k. Alright, so our vertex is going to end up being a 3 over 2, comma 5 over 2. And that is it. We found our vertex. So when we have, so here's another note about standard form. So when we have a quadratic in standard form like the following, right, what we can do is also find the horizontal intercepts. Okay, so sometimes to find horizontal intercepts, so horizontal intercepts are where your function equals 0, right? The x value is where your function equals 0. So those are also called the zeros of your functions, or zeros of your functions. Sometimes it's easy to find those, and you can just factor out the quadratic into like x plus 2, x minus 3, and then you just find them from there. But sometimes it's not so easy. So a foolproof method to find these, we can use a very useful formula. We can use the quadratic formula. So I'll just write ... because it's very dramatic. So the quadratic formula, and I'll write it below. Quadratic formula, and I'll show you a useful way on how you could remember all of it, because it is quite a mouthful. So we have x is equal to negative b plus or minus, because you can add 2 of them, at max 2 of them, b squared and then minus 4ac over 2a. Alright, there it is. So this is the all-important quadratic formula. And again, this helps you find your zeros of your function. Okay? So basically, if you were to set this equal to 0, and this ended up being a not-so-pleasant equation, and you can't solve it just off the top of your head, you can plug all of these guys once you identify your a, b, and c. If you plug it into here, this gives you the x values of your zeros. Okay? That's really useful. So, now back to the useful way you can remember it. I remember when I was learning the quadratic formula, my teacher/professor, they said, okay, so something useful is to sing it along to the tune of Pop Goes the Weasel, I think it is, or something like that. So anyways, and it's not uncommon, so don't think this is weird. And feel free to use it. So basically you would just sing it like x equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so yeah, it takes a little time to get used to, but once you sing it, then, I mean, like, I was singing this in my head all throughout the whole quadratic section of my exam and everything. So anyways, yeah, still use it to this day. It's very useful. So highly recommended. And anyway, so let's see an example of where we actually use this quadratic formula. Okay, so this is kind of an all-encompassing question where we're going to find the vertex, the vertical intercept, and the horizontal intercepts. So for the vertex, let's do part A. So to find the vertex, we just identify, okay, what's our a, b, c, and then we plug it into this formula here, h equals negative b over 2a, which you might recognize as part of our quadratic formula if you look back at it. Anyways, so let's see. So we have h of t is equal to negative 4 times t squared plus 6 times t plus a negative 1. So a is negative 4, b is a 6, and c is our negative 1. Okay? So let's plug it into here. So we have h is equal to negative 6 over 2a, so 2 times negative 4. The negatives cancel out, right? They become positive. We can cancel those out. So we get h is equal to 3 over 4, and that gives us the x-coordinate of our vertex, okay? Or in this case, our t-coordinate, all right? So anyway, so now to find k, we just plug that into our formula. So k is equal to h of 3 over 4. So this is going to equal negative 4 times 3 over 4 squared, and then plus 6 times 3 over 4, and then minus a 1. So when you simplify all of this out, we're just going to get a 5 over 4, okay? We just do the math. Alright, so our vertex is 3 over 4, comma, 5 over 4, okay? And now let's do part B. So part B is pretty easy. I always like finding the vertical intercepts because it's like you just plug in 0 and life is easy. So anyways, so if we just plug in 0, we get negative 4 times 0 squared, yay 0, 6 times 0, yay 0, and then minus 1, so these ones go away, and we just simply get a negative 1. So our vertical intercept is going to be 0, comma, negative 1. Okay, and now for part C, we're going to find the horizontal intercepts. Okay, so that means the zeros of our function, and we already said a is equal to negative 4, b is equal to 6, and c is equal to negative 1, right? So now what we're going to do is plug it into our quadratic formula. Okay, so in this case, t is equal to negative b plus or minus 2a. Sorry, no. Okay, that's because I wasn't singing. That's why. So negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so now all we have to do is just plug in these numbers and then solve for t. Okay, so this is going to be equal to negative 6 plus or minus the square root of 6 squared. So that gives us a 36, minus 4 times a, negative 4, times c, negative 1, okay? And then this is all over 2 times negative 4, which is our a. All right, so that's kind of a lot. But we're just going to simplify. So it's just a bunch of, like, algebra, right? So negative 6 plus or minus the square root of 36. And let's figure out the signs in here. So we have 3 negatives, so that means minus. And then a 16, basically. Okay? And then all over a negative 8. So inside the square root, we're going to have a 20. So negative 6 plus or minus square root of 20 over negative 8. So we can factor out something in there. So this is like saying square root of 4 times 5. So we can bring out a 2, right? This 4 comes out as a 2. So we get t is equal to negative 6 plus or minus 2 times the square root of 5 over a negative 8. And then we can cancel some things out. So if we have like negative 6 over negative 8, for example, well, I mean, we could just cancel 2 everywhere, right? So if we take away 2 everywhere, we just get 4 here and a 3 there. And we can also switch around the negative signs. If you just multiply by negative 1, these ones become positive, and this one's still plus or minus, right? So we ultimately get 3 plus or minus square root of 5, and then over a 4, okay? So basically the way we can write this is we have 2 solutions here for t, one with the plus sign and one with the minus sign. So let me write our solutions on the next slide. So our horizontal intercepts for the given quadratic formula, or function, was, not the formula, for the quadratic function are 3 plus square root of 5 over 4, comma 0. So that's one of them. And the other one is just the minus version, right? So 3 minus square root of 5 over 4, comma 0. And those are horizontal intercepts. Okay, that does it for our concepts video on the quadratic functions. I hope that helps, and I'll talk to you in the practice problems video if you want.
Yeah, overseas nigga, top flow, clear windows nigga, glass house.